Hello and welcome to Notes 2020. Thank you for joining us today. I'm Mars from CityJS Conference. CityJS Conference, a community conference, is a JavaScript festival across London and the world, a joint event from London JavaScript meetups. This is a fantastic opportunity for the JavaScript community and for those aiming to stay in touch with the industry, to be updated on innovative changes around the industry and the JS as an entity. I would like to introduce you to our speaker, Rajesh Gaddipati, a senior application developer at Fujitsu Consulting India, who will be presenting on scrape from multiple sources easily for better visualizations. To give you some background for our speaker, Rajesh has begun his career as a business intelligence analyst in 2010 and then progressed in building complex and high volume data warehouse for analytics. Rajesh has a proficient experience in business intelligence tools such as IBM Cognos, Tableau, Talent, MSBI, Performance Engineering, and Azure Data Lake Store, and is a Neo4j certified professional. He holds two masters in environmental science and history. Thank you and welcome, Rajesh.
Hello, all. Good morning, good evening. So, this is Rajesh, and welcome to my talk on scrape data from multiple sources for better visualizations. So, this is the agenda for today's topic. So, introduction, a power of graph analytics, and we have two visualizations for COVID-19 spread across the continents and homonymous cities insights. So, let's go ahead with the case one. And but before going to that, I just want to give you the background of it. Like when we want to create any new visualization and your data set is not available ready, the options that we have is either we ingest the data from multiple URLs on web pages, or we create manual. So in that case, the web scraping tools, they are very helpful. Like we can pull any kind of data from internet database, like Wikimedia database we have, which can be mirrored. But the only constraint that we have is like all the data is not available on a single web page, and it is not available in the same format. So in that case, we use some coding to identify the data patterns and we pull the data that is required for our visualization. Now let's see our first case. When we start the first case, like COVID-19 virus spread across the continents. So let's start with a question here now. On which date did most of the countries register their index case? So index case is nothing but the first registered case in any specific country. Now to identify that, we go a step-by-step process here, like ingest data from multiple wiki pages. Why multiple wiki pages here? Because Wikipedia has created a unique page for each and every country to understand, to get the details of that particular country situation in this pandemic. Like we have, for example, COVID-19 pandemic in Norway, COVID-19 pandemic in Estonia. These kind of unique pages we have for each and every country. Then we scrape the data from those web pages. For example, we take the required information for our visualization. Then using Beautiful Soup, then we generate the cipher queries automatically for a quick analysis. And then from this data, we can identify the answer to our question. So just to give you a background of the data patterns here. Now info box, which everybody knows here, like info box is something on every Wikipedia page where they give the complete details of all the attributes and values here. So in our case, for this visualization, so we need only the index case location and the arrival date. So that is one kind of pattern we are checking here. And the second thing is the timeline. So from the timeline section in every Wikipedia page, in every Wikipedia coronavirus this spread page, we need the preceding information, the preceding country information, like the virus transmission from one country to another. So for this, we find this information in the timeline section. So this should be done very carefully because the data validation is very important here, where we identify using some before keyword and afterward keyword search and all. So for example, countries with suffix. So there might be a traveler from one country to another. The suffixes of country are very important to identify here, like Indian, Iranian, or Chinese, Japanese. So these kind of validations we need. And one more important validation that we have done for this case is the predecessor arrival date should always be less than the successor arrival date. So which means that the source, the transmission from one country to another, the initial country's arrival date should always be less. So that's makes the logic here. So that's a very important validation that we have done. And the last but not least, the continent information. So we'll see in much more detail here. I'll just go and open a page here. So I'm just opening COVID-19 pandemic in Norway. So you can see on the right hand side, the info box, we have this index case and arrival date. So these information we require, because if you see our question is to identify the date on which most of the countries has registered their index cases. So we need this date information. So we are picking from here. And then comes to the timeline to understand the successor country, from where from which country the virus has transmitted to this country. Okay, particular country. Now we see the keyword searches, the major keywords like before keyword or after keyword or few country suffixes. We can identify the like returning from or a traveler with the countries with the suffix. So these kind of keywords we used here. Now you can see we are going for the timeline February 2020. So this is how we get the information of timeline. Now one more interesting pattern is the information what we require to prepare our visualization is continent information. So do we have continent information here on these pages? No, there is no continent information here. So we need to identify a pattern where for each country, we need to get the continent information. So if we scroll down to the page, we have a section C also. In C also section, we can see COVID-19 pandemic in Europe. Norway is part of Europe. So this is how the unidentified data patterns here. We need to get the data pattern here to get information like this. And if we go for another country here, let's suppose check for Qatar here, we have the index case and arrival date here. At the same time, in the timeline from February 2020, we are just taking the information like the source, the predecessor country information we are picking up from here. Now, if we scroll down to the bottom at the C also section, we have the continent information, COVID-19 pandemic in Asia. Qatar belongs to Asia. So this is how we need to identify few data patterns where we don't get directly data sets. So now let's see, taking this information from these web pages. So we'll go to our code here. So these code available here. We written this code like we are importing 3 different libraries: request, beautiful soup, and Wikipedia. And in the places.txt file, so this is where we are passing our arguments like different multiple countries. We need the information for this. And if you see the directly functions here, where we are parsing this web page here, and we are pulling out the index case and arrival date information from the info box. Okay, and then coming to the second function here, we are having we are identifying the predecessor country information by passing few keywords here in the countries.txt file. We are identifying the predecessor information. Now the last one, the C also section. In the C also section, we are getting the continent information. Now with all these values, we are scraping from multiple different web pages. At the end, we are building a cipher query. So let me execute the query for the time sake. So we can see, so in this query, we are having all the merge statements with all the variables from where we are calling, we are taking all the values and all. So finally, we get the output like this. So now I have passed only one country for the time being. So if we can pass 10 to 12 countries here, you can see this is the output we get here. Now let's take this output directly to our Neo4j and execute there. So here we have this query, same output what we got from the code. So I'm just executing this one. And now let's see the output for this thing. Okay, now when we see, this is the information we got from the query that we had generated from the Python code. So this is only for the 10-15 countries. So this doesn't give answer to our question. So to answer our question, we need the complete data set, right? So let's load the complete data set here. Now I'm just loading the entire data set from CSV here. Now we have the entire data set. So let's execute this query and see the complete information where we have the 6 continents information here with Asia, Australia, Africa. So I'm just placing it in an order here so that we can have a single glance of the entire spread. And here you can see the multiple clusters at the Europe from different countries here. So this is the entire cluster. And now why only you can see there are almost like 150 plus countries only out of 230. Why? Because we know by the March last week 98% of the countries had registered their index case. It is spread to the entire world by March last week. So that is the reason we have scraped the data only for January, February and March. So we can just go ahead and see, we'll execute the query and we'll see which is the date most of the countries have reached the case. So in this query, we are calling the nodes of the predecessor country, we are calling the nodes of the successor country with the relation, and we see that here every country has a property. It has a date property here. You can see different dates. On Australia, the index case was registered on 25th January. So we are calling this date and we are counting the number of countries and doing an order by the descending order. Now we can see the output here. On March 13, 2020, 20 countries have registered on a single day itself. Now, the second highest we see on the 26th February, only 5 countries. But March 13th is a date where 20 countries have registered their index case. Now, let's see, go into much more detail what are those 20 countries and how the virus had spread. So now I'm executing another query here where we have we are matching the predecessor country node to the successor country node, and that belongs to a continent. And since we know the answer, it is March 13th, we are passing this filter to get the nodes only those countries that have registered their index case. I'm just executing this query. Now we can see the output here. Now on March 13, 2020, there are 20 countries registered their first index case, which belongs to 4 different continents here. This is the output we can see very clearly. 20 different countries from 10, the predecessor countries are 10 here. From 10 different countries, it has spread across 4 different continents. Almost like 2 countries has contributed to almost like 50% of the cases on a single day. So these kind of visualizations, when we don't have this kind of data set directly available on the internet, we can use these web scraping tools to get that kind of information and prepare these visualizations. Now, since we seen this and we got the answer, that's March 13th, where 20 countries were registered. That's the highest registered index cases. Now let's do something new, which is not available on the internet. Like now, let's talk about the homonymous cities. So this is, I'll just stop this for a minute. Okay. Now we can see list of homonymous cities. Okay, now you can see here, there is no such kind of web page on the internet itself. Wikipedia has not created this kind of web page. So there is no such page like homonymous cities. Homonymous cities is nothing but a city name that is a city with the same name that is present in different states. Okay, so this kind of information is not available. For the first time using Neo4j, we'll create this visualization today. And just to see, we'll see the process here. Okay, now we follow the same process like homonymous cities. Let's start with the one question here. Which is the most common city name across the globe? If any of you don't know the answer, we'll find it in next few minutes. So we follow the same process step by step here. First, we gather data from multiple web pages. Why multiple web pages? Because each country has its own unique web page. It's like a list of states in a specific country, list of prefectures in a specific country. Like, so we gather all that information, we create our queries, we create our graph database. So we just query on our graph database and we find the answer. So just to understand the data patterns here, so it is always good to go in a structured way. So if you go in a structured way, we can build the relationships very easily. Now you can go and check directly a list of cities in a specific country. Instead, we go in a stepwise manner, list of countries in continents, then list of counties and states in the countries, then list of towns or cities in that specific state or prefectures. So let's go to our Neo4j here, and so I'll just load the data that we have here for the homonymous cities, which was scraped from the internet, from all the countries, from all the states, from all the cities and all. So we'll see now. So this is the output. So just executing. So because we have so many homonymous cities, we have so many cities like that. But the thing here is we need to identify which is the mostly used name across the globe here. So you can see it's more clustered here. because we have almost 500 plus cities. At least they are used more than once. They are more than the city name is present more than once in a different state or in a different country. So this is in a more clustered way. So we have the data set ready. But anyhow, we have our database ready here, graph database with all the information. Now let's execute query on this database to find answer to our question, which is that homonymous city, which is that city mostly used across the globe. So we'll go back to our browser. Okay, and so I'm just executing one query here. So I'm just matching the city which belongs to, which is the city of a particular state, and we are just counting the number of times it is occurring, and we are just doing a descending order and just limit one, which means that we are identifying the mostly used, the most times it is present. This is just one way of writing query. So I'm just executing this one. So let's see the answer, which is that city mostly used across the globe. So we see that San Antonio. San Antonio, so this city with the name San Antonio is there in 34 different states. So we'll see in much more detail. We'll just quickly switch to Bloom, and we'll see in much more detail where this San Antonio is present. Is it in multiple countries like that? So Neo4j Bloom is an amazing tool where we can visualize this kind of information. So I'm just creating a new scene here. So San Antonio. So I'm just entering the city name here. So I would like to know the San Antonio with all these nodes, to which state it belongs to. So state it belongs to, and I would like to know the nations also. So I'm just entering the nation here. So when we execute this, we can see the output here. Yes, you can see it clearly. San Antonio is here. Now San Antonio, this is the same name. So there are many states with the same name, having at least once the San Antonio as a one of the city names. So we have Costa Rica, Puerto Rico, Colombia, and all. So if we see here in a much more detail, so there is one country like United, it's part of United States as well. Okay, so we have Mexico here. We just pull the Mexico to the left hand side, and we can see Mexico itself has almost 9 times. So Mexico has 9 states where San Antonio name is used here. So if we just open this and check in detail, so we know that San Antonio city is present in 34 cities, 34 states. Sorry. So 34 states belong to 17 different nations. So this kind of visualizations, when we have the data available in the graph database, so we can easily visualize much more in detail. Or now, so let's see. So is this the only detail we get? So basically in Neo4j Bloom, we used to find the shortest paths. Like let's say in our case, we'll find the relationship between two countries. Now let's clear the scene here. Now I'm just taking two countries to identify the relationship between them. So let's take India first, and then I'm taking United States. Okay, let's find the shortest path, which means that how the both countries are related. For example, here when we check for the shortest path, yes, Salem, which is a city of Tamil Nadu in state in India. It's a city of North Carolina, which is a state of United States. Now, is this the only relationship? Is this the only states that has this information? Because Neo4j always gives the best shortest path in the randomly. Maybe when next time when we execute, it might be different. So I just want to go into more detail to understand the relationship of Salem's. Okay, so now let's clear the scene here. Now we'll just go, we'll use Salem. So Salem is a city. We need to know what all the state names which has at least one city with the name Salem. So the state, and I would like to know the nation names also. So when we execute this, yeah, you can see here. So many, there are multiple countries. So let's pull the United States here. Sweden also has one of the state where the name Salem. South Africa, Indonesia, Germany, and India. We already seen in the example earlier. So now when we see this, see the arrangement here. Now there are so many states in United States where They have one city with the name Salem. There are almost 18 states in United States. Like there should be some reason, right? Like when we look at the history, there are some amazing books like the Indian tribes of Northern America. So where it talks it about in much more detail. Okay, and there could be many reasons like related to tradition, culture, uh, any trading. So all these things can be discussed in much more detail. So if we see here South Africa, where the Salem is part of, it has a city name in Eastern Cape. It has some biblical origins when we look at the history. So like this, we can go into much more detail, especially useful for the historians, even for the geologists and archaeologists when they are working on a specific relationship between two countries to understand the culture and tradition in more detail. So these kind of amazing information, these kind of relationships, we can build on Neo4j Bloom and can be used across the. So yeah, so now we seen the answer to our question, like the San Antonio is the city name, which is mostly used across the globe. Just coming to the conclusion. So these are all a talk about like scraping data from multiple sources with beautiful soup for creating better visualizations and all. So like this, when we don't have any data set readily available and you want to create a visualization and you have an idea to create something new, definitely internet is our database. And by finding a few data patterns, we can create some amazing visualizations using technologies like Neo4j. And now like we gathered multiple sources from Wikipedia, research journals, and these kind of visualizations, they are definitely helpful in academics and historians. As we see now, it is used across the domains because to get much more deeper insights, and especially for exploring any kind of correlated data, it is really interesting in any context. In any context, when we have much more correlated data, we can find some deeper insights by using these amazing tools like Neo4j. And yeah, thank you all, and thank you Neo4j for giving me this opportunity. So I'm open for any questions.